Okay, we're going to look at solving equations. And from the graphic you're looking at right now, you can see there's actually two things we're going to look at. One is called solving equations by the inspection method, and the other by the balancing method. And it's it's kind of important to not just to follow the rules, but to actually try and understand what's going on. I want to start with a problem here. You can imagine that there are two tables in your classroom. There's a box on one table and three books, a box plus three books. And on the other table, there's 1, 2, 3, 4, 5, 6, 7 books. Now, I took this idea from a Canadian guy who does a thing called jump math. He believes that everybody can do math at a high level. And well, he's kind of proving it. He's taken thousands of people. I kind of stole this idea of equations from him. So just I'll let you know. His name is John Mighton. Look it up on Google, Jump Math. It's pretty interesting stuff. Anyways, here's a box and three books, and there's 7 books. If I say if there's the same number of textbooks on both tables, you know there's the same number on both tables. If I asked you how many textbooks are in the box, I bet you could figure it out. Now, the thing that's interesting is people do it different ways. They do it different ways. We don't all do it the same way, and they're both good. So I want you to take a look at this, and you're thinking, okay, I bet you some people do it this way. Watch this. Some people just look and can see there's got to be 4 boxes and 4 textbooks in the box. There's 7 here. There's 3 here. The only way they could make this 7 is for this to be 4. Just doing that in your head, that method's called inspection. But some people might, rather than even think about it, what they would do, that if there's the same number of books on both tables, there are some people that think, I'm just going to take 3 books off of each table, take the same number of books off of each table, and then it should be they still should be equal. If I take 3 away from here and 3 away from here, they'll still be equal. Well, if you did that, you had 7 books and you took 3 away, there'd be 4 textbooks there. Well, that method would be called the balancing method because we took 3 books away from both sides. Well, we don't know what's in the box. We say we didn't know when we started. We're not sure how many books are in the box. In algebra, that's called an unknown. And what we do is that's what these letters stand for in algebra. That X there, X is how many books are in the box. So X plus 3 equals 7. Well, if we do the same thing, which is the opposite, it says plus 3, we take away 3 from both sides, we end up with the correct answer. That's called the balancing method. What happens if we had 2 boxes here and say 1, 2, 3, 7, and 10 books on this side? If there's the same number of textbooks on each table and the same number of textbooks in each box, well, how many textbooks would there be in each box? Well, a lot of people can look at this and just go, oh, I know. It has to be the same in both. I'd have to take this 10 and break it into 2 equal amounts. It must be 5. Okay, some people are just going to look at it and see that there's going to be 5 textbooks in both boxes. But some people might do this. Some people might take half. Instead of 2 boxes, they take half of 2 boxes, which is 1 box. And then they take half of these books. Half of 10 is 5, and that's how they got their answer. Well, taking half and dividing by 2 are exactly the same thing. But look, it's called a balancing method because we do exactly the same thing to both tables, to both sides of the equation. 2 divided by 2 is 1, and 10 divided by 2 is 5. So this box, each box must have 5 books in it, and that's called the balancing method. Well, I want to show you now 5 different equations. Say you have this, x plus 7 equals 15. If we take away 7 from both sides, we do the opposite of what's ever happening here. Here's x plus 7. We take away 7 from both sides. 15 minus 7 is 8. And 7 minus 7, you're just left with your answer here, x equals 8. But what if we had an equation like this, and it said x minus 7 equals 15? Well, what we have to do the same thing to both sides to keep it balanced. That's what the balancing method is about. And so we add 7 to both sides. Minus 7 plus 7, well, that just cancels. You get your answer, x. See, by doing the opposite, we get to our answer. 15 plus 7 is 22. Now, you can always check your answers. You can go 22, put it back in there, make sure that it's true. 22 minus 7 equals 15. Take 8, put it back in there, make sure it's true. 8 plus 7 equals 15. Okay, what about this one? We have 5x equals 45. It's like there's 5 boxes, and each box has the same amount. Well, we've got to go 5 divided by 5. We do the opposite. You see, x is getting multiplied by 5. We've got to divide 5. And whatever we do to one side of the balance, one side of the equation, we do the same thing to the other. Sometimes they call that a golden rule. 45 divided by 5 is 9. So x must be 9. Then you could go back and check it. 5 times 9 is 45. Now, some people find this harder, but it's actually just as easy. This is called the dividing line. If you see x over 7, it means something's being divided by 7. Well, in order to find out what this x is, you always do the opposite. Now, you have to know that the opposite of dividing is multiplying. So what you've got to do is multiply both sides by 7. Well, the right side's easy. 3 times 7 is 21. That's your answer. When you divide by 7 and you times by 7, those two operations, those two things cancel each other, and you're just left with x. That's your answer. Hopefully that'll help. I've given you 12 questions that practice all the things that we've just talked about. Okay.